not have had any problems with it.
I remember the number 6 in class, and I didn't understand it very well. So
That's quite all right. But once you practice these, you should have no difficulty with it. This is the last one is identical with 1 through 5. It's just that it has a denominator. There is nothing different. So let's go ahead. So 4, 2x minus 3 cubed times 2, 5x minus 1 squared minus 2x minus 3 to the 4th power times 2, 5x minus 1 times 5, and everything divided by 5x minus 1 to the 4th. Is anyone who completed this problem? Okay. First we look at the numerator and we see that there are how many terms in there? Good. So I obviously would like to simplify them as much as possible. I don't like to have a factor in the middle, a factor outside, and then one in the back and one in the middle. So I think that's the best thing to do first, rearrange everything. So 4 times 2 is 8, and then I copy 2x minus 3 cubed, and then 5x minus 1 squared, and then 10, and then 2x minus 3 to the 4th, and then 5x minus 1, everything divided by 5x minus 1 to the 4th. It would be a total tragedy if I would start simplifying these two or these two. That would be an absolute disaster. Okay, so as you mentioned perfectly, there are two terms at the top. So I'm trying to find greatest common factor. So first of all, I look at numbers. I see 8 and 10, and 8 and 10 have something in common, which is 2. Very good. Then I look at 2x minus 3 and 2x minus 3. They have 2x minus 3 in common. Which power will I pick? Very good. And then I see 5x minus 1 and 5x minus 1 in both. So which power will I pick? I cannot pick the highest ever. If this is power 2 and this is power 1, the greatest common factor that is in both cannot be 2. Is that clear? Because it's tempting to say 2, right? But we want to clarify why it's not 2, but it's power 1. Good. So now we open a bracket. We copy the denominator. And now I'm asking myself, okay, from the first term, what did I take out? I take a 2 out, so what is left in brackets? 4. Very good. Then from 2x minus 3 cubed, everything is out. So there is nothing, no remainder inside. But from 5x minus 1 squared, I took 1 out. So what is left in parentheses, in brackets? Very good. So now here's how I check whether I'm on the right track or not. Okay? If I multiply this by this and I get that, I'm on the right track. 2 times 4 is 8, yes. 2x minus 3 cubed, yes. This times this is 5x minus 1 squared. That's it. That's the whole factor. Now I reach this stage with minus. From 10, I took a 2 out, so there is a 5 left. From 2x minus 3 to the 4th, I took 3 of them out. So there is a 2x minus 3 left inside. And there is nothing left from 5x minus 1. At this point, I will have to combine these, distribute, and just get one factor out of this whole thing. At this point, I'm allowed to simplify 5x minus 1 from the top with 5x minus 1 from the bottom because they are factors. So I remove the 5x minus 1 from the top and 1 from the denominator. So from the ones that I had 4 total, now I have only 3. So I copy 2x minus 3 to the 3rd, and then 5 times 4 is 20x, 4 times negative 1 is negative 4, negative 5 times 2x, negative 10x, and then positive 15. Is this okay so far? Any questions so far? Is this okay? Everyone?
I was kind of confused because I see that you just distributed like the 4 to the first one and the 5 to the other one, but for some reason I remember you saying that you didn't like the number in front of. I think it's a different type of equation that I'm thinking about.
So here these are powers, and I have to, if I want to do anything here, I will have to raise them to this power. But I
take away the 2 in front of, like, so the 2 to the 5x minus 1 power to 2.
you're talking
Take
about
away
this.
that 2.
You're talking about this 2 or this 2.
Other 2, not
This
the-
one.
Yeah. not
I
the-
cannot distribute unless I raise to a power by the order of
That's
operations.
what I was confused.
I cannot do that. I have to raise this to this power, and then raise this to this power, and then multiply them, and then distribute A. But the question here is simplify not by multiplying, but by, what are we doing? How do we simplify? By what? By, what have we done here? From this stage till this stage, what is the process called? Thank you. Very good. By factoring. We're not multiplying anything. But these have to be distributed. I cannot just say, hey, look at this, do it at home or something. You understand? I have to simplify this quantity.
So when you take the common denominator, or like
There is no common denominator?
when
Yes?
you take the 2 out, and when
You mean this one?
you have to put the other stuff, like the other stuff left over from when you divide it by 2 in brackets.
So the question is why I have the brackets here.
Yes.
Okay. You don't like the bracket, or you would like parentheses, or is it the idea of the grouping symbol? Why is the grouping symbol in there?
I think it's just the importance of the bracket.
Because I have to use bracket because I use parentheses inside. But I can use nested parentheses. So if the question is why do we use brackets and not parentheses, it doesn't matter.
Okay.
As long as I know that this goes with this, I'm fine.
Okay.
Now, if the question is why I need to use any grouping symbol is a different question.
Kind of both.
Okay, so now let's go back before we finish this. Let's look here. Let's say I have x to the 4th plus 3x squared. What is the common factor here?
X squared.
Right, and then what do I do? What is the next step?
X squared plus 3.
I can't. If I don't put something in there, I cannot write that.
Okay.
So what do I have to write?
You write parentheses.
If I don't write parentheses, it will make no sense.
Okay.
So if I just write this, then what does this mean? It means x squared times x squared. It does not mean x squared times 3.
Okay.
So then I have to use parentheses because from these two terms, I took out x squared. From the first one is left an x squared. Then I have to write plus. And from the second term, 3 is left. So now I can go back if I want to reconstruct and check my work. I can say x squared times x squared, x to the 4th. Yes. X squared times 3, 3x squared. Yes.
Thank you.
So if I don't use this, then I will not be able to show anyone why this times this is this, and this multiplied by this is this.
Thank you.
Is that better?
Yes.
Okay. So this looks fantastic, but it's really nothing else but this. Just that it has more terms. I mean, not more terms, 2 terms, but more factors. So now let's continue and finish it up. Is this clear? How we got from this point to this point? So I distributed 4, I distributed -5. Is this clear? But now I have to combine like terms, and that will be the last step. So this is 2x minus 3 cubed, and then 10x. I'm missing something here? No. Okay, plus 11. 5x minus 1 to the 3rd. And this is it. I know I sound like a broken record, but the first step should be redo the problems we did in class. That's the first layer of, yes, any questions? Go ahead.
Oh, okay, never mind. I understand. I missed the part. I completely skipped over it.
Okay. Other questions here? Is this okay? It is wise to solve the other 5 or the other 4 leftovers from last time and check the answer and check your understanding on factoring by simplifying by factoring. Would you try that, please? so we don't fall behind? Okay. Is there anything else that you tried, anything else that you had difficulties with, or you just simply want to see it again? Anything else? Anything else? Okay, last time we stopped at evaluating functions. So let me just refresh your memory on if you'd like to give me any quadratic function, anything that you can think of, because I would like to show you something, how to evaluate a quadratic function for different expressions or different numbers. Anyone? Any quadratic function? So let's say negative 3x squared plus 7x plus 10. Is this quadratic? Okay, so let's suppose I would like to evaluate this quadratic function for f of x. I would like to determine f of x plus h or evaluate it when x is x plus h. What will you recommend I should write?
-3.
Yes, and then?
Parentheses.
Yes.
X plus h,
Yes.
and then close parentheses squared
Very good.
Plus.
Awesome.
plus 7.
Yes.
Parentheses x plus h.
Perfect.
Close parentheses plus 10.
Very good. Awesome. Do we all agree with this? Do we see it? Do we understand it? Any questions? Is this okay? Very good. So let's continue simplifying and you'll see why, because we're going to get to something today about this. What will be the next step? What do you think? What do I do? What do I write next?
Do not distribute.
Can anyone tell us whether we will distribute 2 inside 5x minus 1 squared? No, we cannot do that by the order of operations. Good. So then,
Write out x plus h times x.
I'm done with that. That was the first day of classes. If you want to foil it, you can. No, it's not a mistake. It's not a mistake, but I refuse to write because I would like us to move forward. So, can anyone give us the x plus h everything squared? It's the first handout we filled out at the beginning of the... Very good. So then plus 7x plus 7h plus 10 equals negative 3x squared minus 6xh minus 3h squared plus 7x plus 7h plus 10. If you are resisting that, I'm fine. There is no problem. But I can go back. We can go back in time. We agreed. We're moving forward. At some point in time, you will join us.
Writing it out like that helps me visualize it better in my head.
That's absolutely fine. You must do what is best for you. But I have to move forward. I have to pull the group forward. I don't want to foil. This is past history. Because, again, why is it important? Because then we're going to get to situations in which this is given and I have to come up with that. Then I will have terrible difficulties going backwards. So that's why I would like us to move forward as a group, if possible. So there is nothing, I don't have anything against foiling. Okay, so we will be using this very shortly. Okay, from section 2.1, let's take a look at one more graph I would like to show you after then evaluating. I would like to look at 2 different graphs and identify the domain and range. And then I think we're ready to move forward. So let's suppose I have this graph. You will see this function in chapter 3. And here's the graph of the function. This graph, and here I would like us to determine the domain and range, nothing else. And here's another graph. The same question. Just find the domain and range. Okay, so remember, domain means all x values for which the function exists. Imagine that you cut it with vertical lines and see where it exists, and that will give us a domain. Can anyone give it a shot on the domain of the first function? First of all, is it a function? Yes, by the vertical line test, this is a function. Perfect. Can anyone identify its domain? From the leftmost point where the function exists till the rightmost point where the function exists. What do you think? Awesome. Union? Excellent. Do you all see that the function is undefined at 3? Perfect. You will see this function in chapter 3. Great job. Now the range. In order to determine the range, imagine that we cut the function with horizontal lines from the lowest possible y value till the largest possible y value. Yes, awesome. Negative infinity to 0, union 0 to infinity. Do we all see and agree with the domain and range? Awesome. Thank you. Now I would like to do the same thing for this function. By the way, is this a function?
Yes.
Yes, by the, exactly, by the vertical line test, this is a function. Perfect. So now I would like to determine its domain. Great job. Can anyone give us a domain? Excellent. With parentheses?
No, it would be.
Awesome. No? So if I put a bracket and 3 here, then this domain will say that the function is defined at 1.3, as well as 1.9, as well as 2.1, as well as 0, as well as 0.5. So I can't, because it's not defined at 2. It's not defined at 1.1. It's not defined at 0. It's not defined at negative 0.5. It's not defined at 0.5. So, say it again. So where does this function exist? At negative 1, at 1, exactly, and nothing else. So if I use a parenthesis, or I use parentheses, I should say, or open interval or closed interval, I am telling you that the function exists everywhere. But that would be a lie. I would be lying to you. This function exists only when x is negative 1, only when x is 1, and only when x is 3. That's why I have to list those 3 elements. I cannot use braces, I cannot use parentheses, I cannot use brackets. I must use braces. When I list all the elements and they are finite, because I cannot list infinite, right? Unless I state a property. But if I list a finite number of elements, I have to use braces.
So if it was from -1 to 3 and there was a line connecting it.
Yes, if there is a curve, that connects all these points, I would have used the bracket 1, 3. But since I only have 1, 2, 3 points, nothing else, I cannot change the graph. This is all I'm given. This is the given function. Then I have to find the domain based on what I have. Good, awesome. And now the range. Very good, awesome. That's it. And we are listing exactly 3 elements. Therefore, we have to use braces. Wonderful. Well done. So that's pretty much all we have in section 2.1. Now, I'm hoping that you will find something new that we did not cover from 2.1, and then on Thursday you'll come back with a list and say, I've done my homework and I looked at everything, but I have not seen this. Show me. Okay, so we can share and discuss the problems together. Okay, in section 2.2, it's more of the same thing, and it's really entitled More About Functions and Graphs. More about functions. So there are a few elements here that we discuss that we have to emphasize. And there are three properties of functions. They don't have to have these properties, but many functions do, at least one or maybe two or all three. So basically what we're trying to do here in this section is analyze graphs and learn from graphs about functions. Learn more or different topics, different ideas. And here's the first one. Increasing, decreasing, or constant intervals. So in other words, a function can be increasing, decreasing, or it can be constant. Let's look at a graph, a very simple graph. Let's graph it together. Something like this. These are very important points, and we'll discuss them in a minute. After we discuss increasing, decreasing, constant intervals, we are going to talk about these points. And I'm just making up numbers here. I'm going to say for simplicity 5, 10, 15, 20, 30. They may not be exactly, it doesn't matter. So let's look between 5 and 10 and analyze the graph. And I'm sure we all realize that this function is going up. For any x value between 5 and 10, just for this interval between 5 and 10, the function is going up. Would you agree? Then for the next piece, between 10 and 15, obviously the function clearly is going down. We're not interested from what value of y till what value of y is the function decreasing. We are interested only in the trend. So let's say between 2010 and 2015, the world population decreased. We don't care from which value till which value. Then what will you say between 15 and 20? Yes, obviously it increases. And what will you say between 20 and 30? We don't care. Yes, it is constant, CT. And obviously between 30 and infinity, for x between 30 and infinity, the function is definitely increasing. We will be asked to find these intervals. So here is how I write that f is increasing on, and we'll write the interval in a minute. F is decreasing on, we'll write the interval in a minute, and f is constant on the interval. Okay, so obviously I see that the function is increasing on three different pieces. This piece between 5 and 10, this piece between 15 and 20, and this piece between 30 and infinity. And that's exactly what I'm going to write. So the function is increasing on the interval, all with parentheses, 5, 10, union 15, 20, union 30, infinity. That's all I'm asked to write. We were asked to find the intervals on which the function is increasing. Now, can anyone give us the interval or intervals on which the function is decreasing? 10 comma 15. Again, this is only the x that represents that trend. Okay. And the function is constant on. Very good. We keep all these with parentheses, no matter what. It's just the trend. Good. So this is one of the properties of functions. They can be increasing, decreasing, or constant. Not every function will have all these three. So for example, the linear function that looks like this, what will you say about this function? All the time, on its entire domain. Okay, what about this function? Right, it's not constant or increasing, it doesn't have peaks and valleys and so on and so forth. Okay, very good. So let's come back now to the second property, which is max-min. We're really talking about local. They're also called relative. Max-min. So let's say we're going to use relative. It doesn't matter, local or relative. We are using those two interchangeably. So let's come back to our graph. Obviously, this point is a peak. And obviously, it's a point where the function goes from or changes from increasing to decreasing. So what do you think this point will be? Let's say 10, 100. It will be a point called relative what? If the function goes up, gets to this point, and then it starts decreasing, what will that point be? Of course. Very good. It's a relative max. And it's a relative max because the function is defined on both sides. It must be defined on both sides. It must exist on both sides. And these points here have a lower y value than this one. What do you think will happen here? The function exists on both sides. What will this point be called?
Minimum.
Of course, relative min. Is this a relative minimum?
No, because the function isn't on both sides.
It does not exist on both sides. This is not a relative minimum. It has a name, however. It's an absolute minimum for this function. Why is this an absolute minimum? Because there is no other lower than it. Everywhere on this function, this is the absolute minimum. So this is an absolute min. It's not a relative min, though, because the function does not exist on both sides. There is no infinity as a maximum because I have to have a number. So I cannot say to you the maximum is 1,000,000 and somebody else comes in and says it's 1,000,000,000 and somebody else says no, it's 10 billion. So if I cannot give you a number back, or at least an approximation, but not a symbol.
I realize there's not functions on both sides anyways, so it wouldn't even make sense.
No, this increases towards infinity, according to the way we graphed it.
So there is two functions on both sides, technically?
So this goes to infinity, but that cannot be a maximum. I cannot say that infinity is a maximum. I can say that the function does not have an absolute max, but it has an absolute min the way we graphed it. If I had here an arrow pointing down, then it would have not had an absolute minimum either. But since we started with a full point, this will be an absolute minimum. Now, if we graph this function like this, then this will be the absolute minimum, right? But at this point in time, that is in our graph. Good. So this is the second property, max min. Any questions? Yes.
The local, is that the same as relative? Or-
Yes. Yes. We use both. In some books, you're going to find it as local. In other books, we're going to find it as relative. The same with the absolute. We use absolute or global, max or min. In some books, you'll find it as absolute, nothing higher, or global, nothing higher. The last property that we are going to look at is the property of called symmetry. Functions can be symmetric. It's nice if they are. Okay, it's not unusual, but it's not very, very common either for functions to be symmetric. So let's call it symmetry. And there are two types. A function can be symmetric with respect to the origin, and it's called odd. I'm going to write those two, everything for you. Odd and even. This has nothing to do with odd numbers like 1, 3, 5, 7, and it has nothing to do with even numbers like 2, 4, 10. Okay? It's just the name of a function. Let's analyze both, and you'll see it's not difficult, and then we'll look at problems. I'm going to graph a function. We're going to look at this function extensively in the next chapter. So here it is. Is this a function, by the way?
Yeah.
Yes, by the vertical line test. Awesome. So this is f of x. I'm going to choose a point anywhere on the graph of this function. I'm going to choose this point. I'm going to connect this point to the origin using a line segment, but I'm going to extend the line segment to the other side. So I connected a point that I picked and the origin, and now I'm extending this line to the other side till it crosses the function again. At this point, I'm going to denote the x value by x. And I would like you to tell me what is the y value. If this is x, what could this be? Exactly, but we like the other notation. What is the other notation for y? Thank you very much. Awesome. Now, based on what you see, and you're probably anticipating something here, I'm going to say that this is, of course, do not look at this. And please tell me, what will this be? That's what I said. Do not look at the other one. The other part does not exist right now. So this is negative x. What will this be? Thank you very much. That's what I said. Do not connect to what we just talked about. That's why I covered it. Now, I'm going to ask you this. If this value right here is negative 10, what is this value right here? Is that clear? They are what type of numbers? What can we say about 10 and negative 10? How do we call them? How do we call them? So 10 and negative 10. Negative 5 and positive 5. What are they? They are opposite values, opposite numbers. Awesome. Thank you. So now I would like you to tell me what is the relationship then between this value and this value. In other words, what is the relationship between f of negative x and f of x? And we used the word a second ago. Say it again. We already said that it's opposite. So we can't come up with another name. It's opposite. So what would be the relationship between f of negative x and f of x? So I will write what? Say it again. Yes. Just tell me what to write. Awesome. Yes. F of negative x will? Can I say that they are equal? They are not equal. So then? We just said they were opposites. So if this is 5 How much is this side? Exactly. Opposites. F of negative x will be the opposite of f of x. Does it make sense? Is it clear? Okay, this function is called odd, which means symmetric with respect to WRT, with respect to the origin. Any function for which I can show that f of negative x equals the opposite of f of x, it's a function that is symmetric with respect to the origin. I'll give examples in a minute. Now, is this clear one more time, that f of negative x is the opposite of f of x? So if this is 10, this will be negative 10. Will be the opposite of 10. If this is positive 5, then this will be, yes, the opposite of negative 5. Okay, very good. So let's look at the other possibility. The second type of symmetry, there are two types. A function can be odd, which means symmetric with respect to the origin. In other words, what I graph in the first quadrant, I will copy in the third, or what I have in the second quadrant, I will copy in the fourth. Nice. I don't have to worry about the third quadrant. If I graph here something, I just copy it in the third quadrant. If I know that the function is odd. Otherwise, I can't do that. So now let's picture a function that is even. And here's a function. We'll talk about it again in chapter 3. So this is f of x. Like with the previous example, I'm going to pick a point. So can anyone give us the x and y coordinates? I'll give you x and you'll give me y. What is the y coordinate of this point? Thank you very much. And I'm going to extend this line. We're not looking at the other side. Now just tell me for this point, what will this be? Very good, awesome. And now without looking at the other side, please tell me what will that y be? Say it again. Awesome. That's all I needed. And now we want to establish the relationship between f of negative x and f of x if the function is even. In other words, symmetric with respect to what? Symmetric with respect to the y-axis. So symmetric with respect to WRT, the y-axis. And this is an even function. But what is the relationship between f of x and f of negative x? They must equal each other. So if they are equal, the function is even. If they are opposites, the function is odd. Okay. And now let's look at the problem or problems. So let's say we have f of x equals 3x to the fourth minus x squared plus 7. The question is here, is f of x symmetric? Can I say that this function is symmetric? I don't know. What do you think I have to determine? Look at these two relationships and say, I know. I know what you need to determine because it's present in both. So that must be a starting point. What is present in these two rectangles that I...
f of negative x.
Indeed. This is my starting point. This is what I need to determine. Is this piece, which is common in both? That's my starting point. Perfect. So f of negative x. Obviously, this is why I started with that. This is why we evaluated this function. This time we evaluated for x plus h. But for this problem, I want to evaluate it for... Perfect. Awesome. So now please tell me what to do. Slowly try to understand the pattern, and then you will not make a mistake when you will tell me what to do next. And I'm ready. what do you recommend I would write? Of course, I have to copy what I see. I can't jump over anything. I have to start from left to right. Then, very good. Very good. Yes. 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 That's it. So slowly from left to right, I copy what I need to copy, and then I replace what I need to replace. The function one more time. If this isn't clear yet, it's okay. So the function is telling us this. This is what the function is telling us. And this can be anything. This time, it's negative x. That's why we replaced, everywhere we saw x, we replaced x by negative x, but we needed to put parentheses because it was negative x. Perfect. Now let's try and simplify this fully. Now, how much is negative x to the fourth? Negative x times negative x times negative x times negative x. It's positive x to the fourth. Do we agree? Because there are four negative numbers, correct? Very good. So this is x to the fourth times 3. Then I copy minus. Negative x squared. Very good. Plus 7. I have 3 questions for myself and for you. So we have, I'm just going to copy. You don't have to copy it again, but I just ran out of room. So this is f of negative x is 3x to the fourth minus x squared plus 7. And I have 3 questions that I need to ask myself. Does this equal f of x? If we say yes, the function is then even. Does it equal the opposite of f of x? If you say yes, then it's odd. Or none of the above. Now you can ask the following question. I'm sure it's on your mind. Can I find a function that is odd and even at the same time? The answer is yes. But there is a function that nobody cares about. It's f of x equals 0. Who cares about f of x equals 0? No one. So moving forward, we will say if the function is even, it cannot be odd. If the function is odd, it cannot be even. So if the answer is yes for the first one, I will cross out the other 2. If the answer is yes for the second one, then I will cross out the other 2. If none of the above happens, then I will say the function is not symmetric. So I'm analyzing now. This is what I got for f of negative x. And this is f of x. Which of these 2 relationships is true? Is it this or is it this? Let's try again. This is f of negative x. And this is f of x. Are they the same? Since they are the same, I will circle it's even, and the other 2 make no sense. That's how we determine whether a function is even in this case. Let's try one more. Let's say we have f of x equals x times the square root of 1 minus x squared. This is a different function. It's not quadratic. It's a product of 2 functions, and one of them is a radical. We have the same question. We're asked the same question. Is f of x symmetric? Symmetric? What do I need to determine? What do I need to calculate in order to establish whether it's symmetric or not? Indeed, that's the answer. F of negative x needs to be calculated. So now can anyone dictate? How do I determine this? Very good. This time, negative x does not need parentheses. Just this time. Because it's alone, there is nothing else in front. Is it wrong to put parentheses? No. There is no need though. And then the square root of? Yes? Very good. Awesome. Perfect. There is nothing I can do to the negative in front. Negative x stays as negative x. But what will I write in under the square root? We cannot distribute before we square. So negative x squared is with minus in front. So 1 minus x squared. Do we all agree? Okay. Now I have again 3 questions. I'm asking myself, Does this equal f of x? If the answer is yes, then the function will be even, symmetric with respect to the y-axis. Does this equal the opposite of f of x? If the answer is yes, then the function will be odd, symmetric with respect to the origin. Or none of the above.
I'd say it's odd.
Correct. So first, I see that this is f of negative x, and this is f of x, and they are not the same. Would you agree? So the first one is out. Now you can say, we'll calculate this. No problem. I will. I will multiply both sides of this equation by -1. When I multiply this side, I get negative f of x. When I multiply this side, I get negative x, the square root of 1 minus x squared. And now I'm here asking myself, this is f of negative x, and this is negative f of x. Are they the same? Therefore, I'm going to say yes, and I'm going to cross out the last one. So this function is symmetric with respect to the origin. It's an odd function.
So remember they gave you the f of x, and if it's not f of negative x, you do the opposite of it to find if it's even odd.
You are only given f of x. You are never going to be given f of negative x.
Okay.
You must calculate f of negative x to establish whether f of negative x equals the original function, and we're done, and that's even. Or if it's not even, you check whether f of negative x equals the opposite of f of x, and then you'll say odd. If that one doesn't work, then you'll say the function is not symmetric. It cannot be. I'm not going to graph what I have in the first quadrant in the second because it's not symmetric with respect to the origin. And I'm not going to graph across the origin because it's not symmetric with respect to the origin.
Okay.
And I have a function like, for example, it's a very good question actually. And I have a function like this. Is this function symmetric? No, because what I have here I don't have in the second quadrant. Is this symmetric with respect to the origin? No, because what I have here I don't have in the third quadrant. So this is a typical function that is not symmetric. But the key is to start with f of negative x, check whether it equals f of x. If it does not, then I will construct or determine negative f of x by multiplying both sides by -1, and now I compare f of negative x with negative f of x. If these two happen to be the same, then I'll say it's odd.
Okay. Okay.
If these two are not, then I'll say none.
Okay. All right.
Better? Perfect. Other questions here? Very good question. So let me